Hi, I'm John, and I'm back with another project on one of my models. This time, we're fixing up a garden-scale 2-truck Climax locomotive. More precisely, this is F-scale, which is 1:20.3. I got this model from a clubhouse at a retirement community that was being shut down. My friend Jamie contacted me saying they were going to throw everything away, so I guess I saved it from the dumpster. I'd thought of purchasing a battery, speaker, receiver, controller, and decoder to do a more traditional AirWire style install, but then SoundTraxx released their Blunami large-scale decoders. With a Blunami, all I would need is a battery, decoder, and speaker. I'd be able to use my phone as a throttle, and the receiver's built into the decoder. It sounded like a great way to go, so I contacted my friend George Bogatuk from SoundTraxx, who also thought it sounded like a great idea. SoundTraxx was nice enough to provide the decoder to me for this project, so I owe them a big thank you for helping me out with it. Since I haven't really done any serious work on garden-scale locomotives, I asked another friend, Trevor Park, for his assistance with this project. Trevor has done a lot of battery conversions for the Fern Creek and Western Garden Railroad that has been featured on this channel a lot over the past 9 or 10 years. He agreed, and he's standing by at the workbench. The scope of this project will be to evaluate the model for operability, install the speaker, decoder, and battery, improve the looks, correct any operational issues with the model, then have a test run. Throughout the process, I will be sure to include affiliate links in the video's descriptions, so you have access to the same kind of tools and supplies that are being used in this series. So let's head over to the workbench and get on with the mechanical evaluation.
Hi, my name is Trevor Park. Many of you may recognize me from the Fern Creek and Western Garden Railroad, which John has done lots of videos on over the years. And as many of you know, I have quite a bit of experience putting battery conversions in locomotives. But today we're doing something different. We're going to be doing this install with the Blunami decoder like John talked about, which I'm really excited to try out because I've never used one before. But like any battery conversion, the first step for preparing your engine for battery is actually doing a mechanical evaluation of the engine and doing all the mechanical work and wiring work necessary to get the engine ready for a battery conversion. And this engine is an older engine. It's almost as old as I am, believe it or not. And so today we're going to be going through this engine, making it mechanically sound and ready to go so that we can put a battery conversion in it in the next video. So that's what we're going to do today. So let's get started on this. First off, we obviously have to have a battery, and so that's this blue thing right here. This is a 34 milliamp hour 14.8 volt battery, which is what I use in all of our conversions is 14.8 volts. So a little over 12 volts of power gives the engine a nice little punch, and this is what most battery conversions, regardless of the electronics you're using, use. And this is a nice size for the locomotive because it'll fit right in the tender right here. I've done a couple other Climaxes, and I actually put the batteries in the boiler and cut weight out of it, but because of the fact that we don't have the receiver and all this other stuff, because the Blunami contains everything inside it, we actually have room to put the battery in the tender, which makes the conversion a whole lot easier, more straightforward, and quicker. I have this Visiton speaker here. This I'm actually going to mount in the firebox of the locomotive because you can open up the bottom of the firebox and the speaker will go in there so it doesn't get the sound-making tender effect. It'll actually sound like the sounds in the locomotive.
Oh, cool.
And then the other kind of exotic part, if you will, that you need for this is a battery charger. This is a smart charger that can charge a variety of different battery packs at varying voltages and sizes. It's smart in that it can actually sense, what the battery voltage is at and charge it to a certain level so that it doesn't fry the battery or overcharge or
Start a fire
or anything like that. So these come from T-Energy. They are a huge manufacturer of batteries, and their chargers will work with just about any battery that you want to buy that's of that voltage range.
Cool. So aside from that, we have all the normal tools you'd expect hanging around here, soldering irons, screwdrivers, etc. And I'll put a list in the description of all the tools and equipment and stuff that we're using. We have wire, flux, lots of stuff you'd expect to see. So cool. Well, I guess we should get started then.
Yep, we got a lot of work to do. So the engine we're using today is actually a first generation Bachmann Climax. These were the ones that were released probably around, let's say 2001, 2002, which makes this engine only a couple of years younger than I am, which is kind of funny. In any case, the engine definitely has seen a bit of a hard life. And one of the biggest issues with it is it's missing part of the drivetrain system. The way these engines are set up is Bachmann has motors in each of the trucks that drive the trucks, and then one of the trucks has a gear inside of it that will drive the whole drive shaft and the cylinder assembly and everything on the side. But one of the square shafts and universals and universal horns was actually missing on this locomotive. The universal and the square shaft are still present, though not on the locomotive, but the universal horn, which is what connects it to the engine set, is actually missing. Well, thankfully, this is one of the parts that Bachmann actually stocks still. So I have here a new universal horn in this little bag and the pin that holds it in. And so we're going to put that on the locomotive so it's mechanically sound before we start the conversion. And as part of that, I'm going to also take the rear truck off to see what we're dealing with in terms of wiring, because some of these older locomotives aren't DCC ready. They actually have what's called a non-isolated motor, where the track power leads go directly to the motor within the truck. And they don't actually go up into the locomotive so that you can hook them up to a decoder. So that might mean we have to do a little bit of wiring in order to make that work, but we're going to take it off and check what it has, and then determine how much wiring we need to do from there as part of the mechanical rebuild. So the first thing to get these trucks off is these little spring planks and spring assembly on the truck. This actually slides out the side, and there's a screw behind it in order to pull the truck off of the frame. So the first thing we're going to do is just unscrew these little tiny screws right there, and that will allow us to then get the spring plank and everything off. And there's one on the other side. So there's the other screw out, and now I'm going to grab a pair of needle nose pliers, and if everything goes right, in theory, these should just slide right out. So there it goes. So now we're going to take this screw out that holds this tab in. There's a little kind of fork that goes around the truck, and it's screwed in on both sides. I've already taken the spring plank and the screw out on the other side, so now we'll take this one out. Once this screw is out, the truck should just slide right off, like that. And that'll give us clean access to everything under the locomotive to start working on the drivetrain system, and also to take the bottom of the firebox off, because that's where the speaker is going to go. So we've gotten the truck off, and it is one of the types of trucks that does not have an isolated motor. However, it turns out that the motor leads slip over the track power leads. So you have these two brass tabs here, and this slips over the track power leads so that the track power immediately runs power to the motor, like that. Same thing on the other side. And then on the locomotive, those tabs on the truck then slide up on these tabs here. So it's just a contact fit. And some people might say that, well, you know, you want to solder wires to those to make a more definite connection. However, the problem with that is that it makes taking the truck off really difficult. And so we're going to just reuse these tabs, and we're going to take the track power leads off the locomotive. The reason for that is that if John was to go and run this on a railroad that was running track power, it would be feeding track power up to the decoder, and that could cause some problems with the battery system in it. And we don't want to, you know, mess up anything and fry the electronics. The Blunami decoders can run on track power, but we would have to put an isolation switch in there for the battery, and he has no plans of running this on track power. So we're just going to do this simply and take the track power pickups out of the engine, and then the motor leads will just slip on to these. And the nice thing is that when you then take this off, there's a screw right here that takes this plate off. That then reveals a plate under there. These little brass studs, which are actually spring-loaded, ride on the plate that's right there. And what is really nice about that is there's no wires to snag, so the truck has free range of motion side to side. This will allow the power to run from the decoder down to the motors. There's one of these on the front truck, and then this one here on the rear truck. and that will allow the motor power to run down here without having any wires that could possibly snag as the truck is moving side to side. So since we have the truck off, the locomotive, it's a good idea to test it before you put it back on the engine. And the nice thing is with the track power leads and the motor leads all hooked up on these plates, you can just take a little alligator clip and hook it on up to those.
Yeah. I'm a big proponent of testing stuff while it's apart like this.
Absolutely. And this, Bachmann engines, some of the older ones especially, are notorious for having issues with the gears. This is a really good way to make sure that you're not putting a nice expensive battery system into something that isn't going to work. So we'll lift the truck up off the table here, and I have a standard 12-volt power supply for, like an HO scale engine just off to the side here, and it's enough to get the motor moving here on the locomotive. So we'll turn the power up, and look at that.
Oh, that sounds chunky.
We'll try the other direction, just make sure. So, it runs. Before we connect all the driveline pieces, I mentioned that we're going to be putting the speaker in the firebox here. This bottom plate of the firebox actually comes off like this, and you can access it and put stuff in there. This is actually an aftermarket reed switch that someone added for a chuff sensor, for older sound decoders that would use, a chuff sensor and didn't have something like back EMF to be able to detect motor load and stuff like that for timing the chuff. But with this cover off, we can put a speaker in here. And the reason I'm taking the cover off first is once you put the driveline on and the horn and the universal, it makes this plate kind of hard to get off. And so it's a way easier to work on it now while all this is apart and the rear truck's off and everything. We can put the speaker in. We'll probably actually use these wires here that are already here for the reed switch because they're already run through the engine. And then we will end up putting the cover plate back on once the speaker is installed and then install the driveline components. Now, all the older Bachmann engines and most older engines that have some of smart electronics but no DCC have spaghetti boards, as I like to call them, because this board here, it actually has the LEDs for the firebox flicker effect on it, but on the back side it has all of this, and we don't need this board. This board has all the resistors for the LEDs and stuff on it, and all the spaghetti for the smoke unit and control switches and all sorts of other stuff that you won't need with DCC. And of course, what makes this really fun is everything is red and black, which means you don't know what they all mean. We'll end up installing new LEDs for the firebox flicker, and once all this stuff is out, we have this nice big space up in here for the speaker to go. So the next step is to actually start tracking all of these wires, figuring out where they go, and ripping out all of the unnecessary stuff that we aren't going to need. A lot of those unnecessary wires actually run up to the front of the locomotive here, because not only do you have the power coming from the trucks to the back of the engine from the track power pickups, but you also have a chuff cam here inside this cylinder, and the cap's missing here. We'll replace that later with a new part, but the big user of all of the wires is actually the smoke unit up in the front here. And this smoke box cover actually just slides off like this and reveals a switch here. This controls the smoke units on off, and as you can see, a lot of the wires have actually already broken off of it. And then the smoke units in there, the wires for the headlight here, and a bunch of other stuff. So anything that controls the smoke unit, this switch, the wires there that lead to the unit itself, we don't need any of those. And as a matter of fact, all the wires going to the chuff cam and the cylinders, we don't need those either, because this particular decoder is modern enough that it has back EMF and you don't need chuff sensors to control the chuff. So all of that superfluous stuff is going to get taken out of the locomotive. It's going to clean things up a lot, and then we'll have a much better idea of what we're working with and can then effectively have a nice clean conversion. Now, all this work to get all these wires out is very fiddly, and I'm going to have the engine in all sorts of awkward positions where I can actually see what's going on and see what wires I'm trying to track. So we're going to do this off camera, and by the time we come back, the engine is going to have a haircut, as Kevin likes to call it. If you watched our video about the 3 professionals installing a DCC decoder here on TSG Multimedia.
Gotta trim the short and curlies.
And then once we come back, we'll have it all nicely cleaned up and we can proceed with the battery conversion. We also took the front truck off of the locomotive while we were doing the whole process of taking the wires out and tracking everything, because The front truck was in the way of the motor lead wires, plus the wires that went to the chuff cams and the 2 cylinders. So in order to get those out and track them properly, we needed to take the front truck off. We also took this opportunity to test the front truck to make sure that the power worked correctly and that the motor spun and everything checked out. So it means that we can use both trucks as is and not have to do any work on them. Okay, so we've cut out the main motherboard, if you will, of the engine, which is this part that I'm holding right here. And all of these wires here came into that. So it was a matter of tracking what all of them were, and then I put these little labels on. It's just a piece of blue tape with a Sharpie with some acronyms, like this BL is backlight, headlight plus, so anyway, it turns out they did do some color coding. All of these black wires go to negatives, red wires go to positives, so at least they got that part right, which makes it easy to hook it up later. And then got all those wires tracked going up into the boiler, and then we also ripped out all the stuff we don't need. This here is the smoke unit. And we don't need any of that. I don't use smoke units on anything because A, these older Bachmann locomotives don't produce very good smoke, and they draw a lot of power off the battery. And so you don't want to have that. So we'll get rid of that. So anyway, these are just random wires that went back to the tender, likely for track power coming from the truck and maybe some other electronic bits that were back there. We don't really care about these at the moment. But eventually what we will do is the applicable wires that go back to the tender will get hooked up to these, and they go through this little channel right here and back up into the tender. So that will be how we get the power back to the decoder, and then we'll tuck all of this up into the firebox and mount the speaker right on top of it. We're going to take the tender off and kind of plan where everything's going to go in there, and also to see what situation we're dealing with in terms of wiring. So normally, if this engine was complete, there'd be 2 little water shut-off valves that go into these 2 holes as plugs. But if you remove those, then there's these holes that hold the screws in there, and then there's tabs on the back of the tender that lock it into the frame. So just with the Phillips head screwdriver going down there and loosen the screws up, and then the tender should just lift right off. So, as you can see, there's just these bare ends coming up into the tender, except this wire here, which we'll actually just pull out right now, because this is the leads for the rear truck, right down there. And the way this is going to work is the battery is going to go on the bottom, something like this, and then we'll take our Blunami decoder, which is still in the package here, but it'll go on top, and all the wires will plug in on the sides there, and then the tender will just sit right on top of this, and the speaker will be in the firebox like I mentioned. What I'm going to do is actually run color-coded wires. I don't have all the NMRA color coding proper wires, but I am going to run color-coded wires up just so that we have a better idea once everything's in the engine on how to wire it all up. And also, if we ever need to do maintenance, replace wires or something like that, we know where everything's going to, and we know the color coding. So all that's required to get the channel off is just to take this screw out here. And then once you're done taking the screw off on top of the channel, then there's actually screws you have to remove underneath. These are actually the ones that hold the truck and the bolster plate and everything on, so you have to remove the rear truck like we've already done, and then everything it mounts to in order to get that channel off. It's only 5 more screws, and then you have it off, and it's way easier than having to pull all the wire through. So after about close to 2 hours of work of cleaning wires up, we have a really nice clean area to put the speaker now. It looks a lot better than it did before. Basically, the way we have it set up is I've grouped all the wires together through the channel that runs back behind the firebox I showed earlier. And now all the wires are tucked up at the top so that we can bring our speaker in, and it fits very nicely right up into the firebox there. And we'll stick it in with probably double-side stick tape so that it has a nice secure connection in there. It does have these screw mounts, but there's nothing actually up there to mount it to. And that's what these 2 bare wires in here are for, is for that speaker. And those will go back to the decoder. Now, if we look in the tender, We can see all of the wires are now up through that channel into the tender. A lot of them are way too long right now, but I just cut enough so we had plenty of excess to deal with. But we have mostly everything color-coded. And some of the wires that, are for the same thing, like multiple LEDs, they go to all the same spots and that sort of thing. So we now have everything up in the tender so that we can then install the battery and the sound decoder and all of the stuff up there once we get the firebox buttoned up with the speaker and everything. Okay, so as I mentioned, we have these two wires coming in here. It doesn't matter what color they are for positive and negative for the speaker unless you were to wire it in series or parallel with a second speaker. So we're just going to bring our wires in here, and the pads have these nice little holes in them, so we'll loop the wire through those holes so we get a nice secure connection. And then I'll come back with some flux, and we'll solder these to the pads. So now we're going to stick some double-sided stick tape up in this corner, because one of the nice things about this tab that screws in is it actually wedges into the corner of this firebox really nicely, so we can get a nice secure fit of the tape right in there and seal the speaker in. There we go. So we'll just use some tweezers here to press it down to the tape a little better in a couple of areas, just so we know we have it securely mounted. And now, even if you tap on it, you can see it's in there. And now the final thing is just to take the firebox cover and snap it back on there, make sure it all fits right. It slides into these two tabs in the front first, and then clicks in the back, like that. There you go. Now you have a little speaker enclosure that's kind of made for you in the firebox, and it'll come out these holes, which would be the damper on a real steam engine out the side, and produce a real nice, good sound. Since we're going to have the engine back upright, I want to put the wheels and trucks back under it. And I mentioned they are non-isolated motors, so the power goes directly from the pickups on the trucks to the motors within the truck itself. Well, John doesn't want to run this engine on track power ever again, so we're just going to pull the pickups out. That's going to make things really easy. Then we don't have to change any wiring in the trucks whatsoever. We just have to pull the pickups out so that the wheels are isolated from track power if they were to eventually contact track that was, using track power, so we don't fry the decoder or anything. So all we have to do is take the bottom plate off the truck, which is these 6 screws right here. So now this plate coming off reveals all of the gears and stuff inside, and you can see the pickups, which are right there. And these little cylinders have a little plunger in them that contacts the wheel with actually something that looks like a little piece of lead shot that's basically a little ball that rolls along the back of the wheel, and a spring in there that keeps it pressed up against the wheel. So when we pull these out, they might self-destruct. And so you want to just, as gingerly as possible, pull these out and just know that they might not come out in one piece. So you can see there's the spring and the little ball at the end. So we're going to save these parts just in case for whatever reason we want to put them back in. The chances are almost none, but we're going to save them anyway just in case. And so we'll just do that with the other 4, and then once you've done that, not only do you not have track power going to the wheels anymore, so you won't fry any electronics, but it also reduces the drag on the engines. While they might be little ball bearings along the back of the wheels, it does, add to the resistance slightly. And we want to reduce the amount of drag in every way possible. And now we have trucks without pickups, and now we can just easily put them back on the locomotive, a reverse process of what we did to take them off. So we're getting close to being ready to install a decoder, but before we do that, I mentioned there was some work to be done to the running gear. And now that we've done everything inside the firebox, we can put the running gear back together. So this right here is the universal horn, and this presses onto the shaft coming out of the engine set here. And there's actually a little pin, this little tiny pin right here, that goes through a hole on that shaft. And then that actually goes into the universal here, and that plugs in then to the square shaft that goes to the rear truck of the locomotive. And there's actually 2 screws that hold this universal joint together so we can separate it and put these horns in it once it's all assembled, and then we'll have the drivetrain all back together and the engine should be functional again. The drive shaft on this locomotive doesn't actually drive the trucks. As a matter of fact, it's the exact opposite. The trucks are powered on this locomotive, as I mentioned, and there's gears inside of it that actually use the drive shaft to spin the cylinders and the engine set on this engine. So it's really the exact opposite of a real geared locomotive. Okay, so now all the driveline work is done, everything's reconnected, the universal is reassembled, and the engine is ready mechanically for operation. So the next step is to install the decoder. We have all the wires pulled, the trucks are dealt with, the pickups are removed, so there's no chance of frying the electronics in there, and everything's cleaned up on the inside, even the speakers installed. So at this point, all we have to do is put the decoder in, put the battery in, wire everything up, and then test run the locomotive. And this is a good place to stop for now, because the decoder installation will take a little bit of time, and then we also have to do some cosmetic work to the locomotive to fix some of the defects from the years of it running on someone else's railroad. So for now, we'll leave it here, and then we'll come back at some point in the near future, install the decoder, and get this thing running on the Fern Creek and Western for a test run.
Thanks for that, Trevor. It looks like we're well on our way toward having something railworthy. I think putting the speaker in the firebox was a good decision. It should leave plenty of space in the tender for the battery and decoder. In the next episode, we'll see how the decoder and battery go in. Be sure to subscribe so you don't miss the next episode. And if you find this content worthwhile, share it with your friends. I'll see you next time.